Okay, guys, today we're going to be talking about the distributive property. It is something that you will be using now through calculus. So it is one of the more important things that we are going to review from middle school. So please make sure you give this video a watch. It is one of the longer ones. I'm going to warn you now, but it is worth watching every minute of me going through this with you because this is a skill you will be using the rest of the time you are in high school. I promise you, okay? So, the distributive property allows the number outside of the parentheses to be distributed to the terms inside the parentheses. So I know that probably doesn't make a lot of sense, so I'm going to kind of visually show you what that means, okay? So we've got the situation that says each of the 4 members of the Robinson family ordered a drink, 2 slices of pizza, and an ice cream cone. So I know that I'm going to take 4 times the number of sodas each person got, 4 times the number of pieces of pizza they got, and 4 times the number of ice cream cones each person got, because there's 4 members of the family, okay? So looking at this first problem, I'm going to put a 1 there in front of my S as my coefficient because each person only got 1 soda. So 4 times 1S is 4S. Now looking here, each person got 2 slices of pizza, so my coefficient here is going to be 2. So 4 times 2P is going to actually give me 8P, okay? And then 4 times the 1 cone is going to give me 4 cones. So you can multiply, okay, the 4 and the 2 here. I know earlier we learned you can't add them, but you can multiply them, okay? So I distributed the 4 to each piece of the meal that was inside those parentheses, okay? So one way we can represent the distributive property or solve these problems is to use an area model. So thinking back to middle school, the area of a rectangle is the length times the width, okay? So looking at number 4, the width of my rectangle is going to be 5. And I'm going to split it into length 1 and length 2 since I've got 2 lengths. And my length 1 is going to be that 3x right there. And you guessed it, my length 2 is going to be the 2 that is on the second rectangle. And just so you kind of know, the original expression that we were working with, it kind of upsets me that it doesn't give it to you. But that original expression can be written as 5 times, or parentheses, 3x plus 2. Okay? So that is what our original expression looks like. So as you can see, the width is what goes outside the parentheses, and the 2 lengths are what go inside. And you're always adding them unless there's a negative sign in front of one of the numbers, okay? So I'm going to go ahead and find the area of this first triangle. So like we said, length times width. So 5 times 3x. And that is going to give me 15x. So I'm going to put 15x in that first box there. And now I'm going to find the area of that second rectangle. And this one should be pretty easy for us because we know that our width is 5 again. And this time we're going to use length 2, which is 2. And 5 times 2 is 10. And since we don't have any negative signs, both of our numbers here are positive. Our new expression is going to be 15x plus 10, okay? So right now, I want you to try to do number 5 by yourself, okay? And I want you to see if you can find the original expression. So I want you to try to do that on your own. And go ahead and pause the video and do that. So here we're going to start. We're going to label our width as 7, our length 1 as x, and our length 2 as 9. So our original expression, what you should have automatically thought to do, is to put that 7 on the outside of some parentheses. And inside, you know that x and that 9 have to go in there, and that there's no negative signs up there, so they are added, okay? So we are going to go ahead and start. We're going to find the area of that first rectangle there by doing 7 times x, which is 7x. And then we are going to find the area of that second rectangle, which is 7 times 9, which is going to give us 63. So our new expression is going to be 7x plus 63. So now I'm going to work out some examples with you guys. So this first one, we've got 8 times 4x minus 12. So when we're solving these with that area model, I'm going to walk through the area model and the normal way to solve it. Either way that you choose to solve these is totally valid. And I promise you, I will always give you enough time that you can do either way that you are more comfortable with on a test. You just need to do what makes you comfortable. So remember that number outside of the parentheses is always going to be your width of your rectangle. Okay, so we're going to go ahead and slap an 8 on the outside here. And then we are going to take that 4x. That is going to be our length 1. And that is going to go under the first rectangle. And that minus 12 is going to be our length 2. Okay, so the minus 12, you have to keep the negative attached to the 12. Okay, have to. So you see, I wrote that as a negative 12. If you have a minus anything, you have to keep the minus and the number together. Okay, so we're going to go ahead and set up our math over here. And the math over here is just exactly what you'd be doing if you were doing it that normal way of distributing. Okay, so if you didn't want to draw this to kind of help you organize your thinking, this is just all the work I would need from you, okay? But if you need this to know what you need to be multiplying, that is okay too. So we know that 8 times 4 is 32, so that is going to give us 32x, and 8 times a negative 12 is going to give us a negative 96, and the way we write that is 32x minus 96. Okay, now this next one might kind of freak you out a little bit because it's 3 terms inside the parentheses, but that is absolutely no big deal. We can do it the exact same way. Okay, so instead of having 2 boxes inside that rectangle, you guessed it, I'm gonna put 3, and we're gonna just roll through it the same exact way we've been doing it. Okay, so while I draw that, just remember, if you're doing it the normal way, you're taking 5 times 3x, 5 times minus 7, 5 times 4y, and getting your new expression. If you like the area method, that's fine too. Okay, so you can see I just label my boxes just in the order they go, write my math out over here, and we're going to work through it just like we've been doing. It's nothing new. Even though there's a 3, it's nothing new. So we're going to start with 5 times 3x. It's going to give us 15x. And then we've got 5 times negative 7, which is going to give us negative 35. And we've got 5 times 4y, which is going to give us 20y. So remember, when we rewrite this, we use addition. Unless we've got that negative sign, then we use subtraction. So we've got 15x minus 35 plus 20y. And I'm just going to go ahead and highlight all of our answers here so you can go back and find them easy if you want to do some practice or check your work. So go ahead and pause the video, and I want you to do this bottom one on your own. So now that you've tried to do this on your own, I want to make sure that you started here with what I circled, because there's not really much we can do with that 6x right now. So we're going to go ahead and start to solve this. I'm going to continue to use the box method. Like I said, if you don't like it, you do not have to use it. I put my 2 on the outside. I put my 5x on the bottom as my length 1, and that minus 6 is my length 2. Set my math up over on this side. Remember, you have to do either this, or this as showing work, okay? You got to do something, okay? You can do both, or you can do either or. But we've got 2 times 5x. It's going to give us 10x. And then we do 2 times negative 6, which gives us negative 12. And so I have to erase because I'm running out of room here. So give me just a second. When I rewrite my expression, I've got 6x, not 60, 6x plus 10x minus 12. And now I have to actually combine my like terms, which I'm going to do, to get 16x minus 12. So that one just